So let's take a look at some other possibilities we can see graphed here. So when I'm doing it, I'm always going to do the same process. If it is not just points, if it's a continuous line like what we see here, then I'm going to do it as increments of values. The domain is still represented by x. So I'm going to say is x, where the lowest point, well, it doesn't have one, keeps moving to the left. The highest point doesn't have one, keeps moving to the right. Just x, e, r. For the range, well, it looks like this lowest point here is at the point of -3. So my range is going to be represented by y, and in this case, y has to be bigger than or equal to -3, but it can be any other number. When I get to example B, then I'm going to say the domain, which is represented by t in this case. So make sure you're checking for your variables. Has a lowest point to the left here of -2, so go furthest to the left, is less than or equal to the variable, which is less than or equal to the highest point over here is going to be 4, where t can be any number in the element of real numbers. The range there we go, sorry. The range is represented by P, where it has a lowest point of -3 is less than or equal to P, which is less than or equal to its highest point of +1, where P can be any real number. When I get to my mapping or arrow diagrams, it makes it really easy because they already have it arranged in numerical order for us, and they already get rid of any repeats. Even though it have 1 and 2 and 1 and 6, I can just list them out. The domain is going to be represented by 1, 2, and 3. And the range is going to be represented by 2 and 6. D is a little trickier. For D, it might even be better if we just draw a little picture of what this would look like. If I have a circle with a center at -2 and 3. So I'm going to go left 2, up 3, and this is the center. And it says that it has a radius of 3. Well, if the radius is 3, then it means that it could go 3 to the right, it could go 3 to the left, it could go up 3, or it could go down 3. And then I have my circle. So that means that I can go from here, I can subtract 3 or add 3 for the x, and I can subtract 3 or add 3 for the y. For the x, or the domain, I'm going to say that the lowest point is going to be -2 minus another 3, -5. Is less than or equal to x, which is less than or equal to, if I take -2 and add 3, I'm going to have +1, where x, e, r. For my range, it's represented by y. If I take 3 minus 3, it's going to be 0. And 3 plus 3 is going to give me 6, where y, e, r. if I want to draw a possible relation which has a domain of XER, so it keeps moving left and keeps moving right, but a range where y has to be less than 2, and it, in the first case, only has one intercept, one x-intercept. Here's my axes, and to have something like that, I know it's going to have to keep moving to the left. It's going to have to keep moving to the right. And it can only move down, not up. If I want one that has two x-intercepts, that one's a little simpler. It means that it keeps moving to the left, moving to the right, and moving down from a starting point of the highest point is going to be 2. So I can stretch it down like that and stretch it down like that. Explain why is it not possible to draw a graph which has a domain of XER and a range of y is less than 2 and no x-intercepts. Well, if x-intercept means y is equal to 0 and y is any number less than 2, because 0 is less than 2, an x-intercept has to exist. Okay, last one. A high school football team is hosting a banquet to celebrate winning the championship. The caterer charges a setup fee of $500 plus charges an extra $20 per person. If the equation C is equal to 500 plus 20n represents the cost of hosting the banquet for n people, then make a table of values with 8 entries with a minimum of 100 and a maximum of 500. Well, let's just pick some numbers here. We're going to say that it's going to be 100 people, 200 people, 250 people, 300 people, 350 people, 400, 450, and 500. You could pick whichever numbers you want. When I plug it in, when I replace the n value in this equation with 100, 500 plus 20 times 100 is going to give me 2,500. If I do 200, it's going to be 4,500, or 5,500, 6,500, 7,500, 8,500, 9,500, and with the maximum 500 people, 10,500. All right. If I'm plotting the ordered pairs on the grid, then the first thing I have to do is I need to pick out what my scaling is going to be. If I need to go up to 10,500, then my scaling for the C values along here are going to be pretty big numbers. Let's make each one of these, or every fifth one, 2,500, which means every line is worth 500. This would be at 5,000. This would be at 7,500. This would be at 10,000. And this would be at 12,500. For my n values on the bottom, I have 1, 2, 3, 4, 5 of the bigger lines or 25 of the smaller lines. If I only need to go up to 500, I'm going to make every fifth line worth 100. So there's 100, 200, 300, 400, and 500. And this starting point is going to be at 0. I'm going to graph it out, and it says that it starts at 100 and 2,500. Well, there's my point right there. The next point I picked was 200, and at 200, it said that's going to be 4,500. There's my point. I'm going to skip ahead. I could do the 250, but it's going to be in between 2 points. So let's go to the 300 where I can use the clear lines and do 300 and 6,500. And that's going to exist right here. 400 and 8,500 is going to be right about here. And 500 and 10,500 is going to be right about here. And this is all going to make a nice straight line because I have that linear function. If all possible ordered pairs were plotted on the grid, what's the remaining range of the relation? And explain why there are restrictions on both. Well, for the first, I'm going to say that for my domain, it's represented by n, and in this case, the lowest value is going to be 100, which is less than or equal to n, which is less than or equal to 500. And because I can't split people in half, I'm going to say that n is an element of natural numbers, or nen. It's not real numbers because it can't have a partial person. My range is going to be represented by C, where the lowest value down here is 2,500 is less than or equal to C, which is less than or equal to the top point here, 10,500, where CEN. So when I'm talking about the restrictions, I just have to do, based on the problem I'm given, can I have partials, can I not? Now I know that there's going to be a lot of points that are going to exist, so I still connected the dots in between here, but I'm just going to state that it just has to be natural numbers. All right, get some practice done with this.